Hello, this is Derek, and this is section 7.3. It's actually going to be multiplying and factoring special products. So there's three special product formulas we're going to look at. The first two involve the same signs, so this is a plus b quantity squared. So what this is actually standing for, I wrote it out here a little bit larger, is a plus b quantity squared is a plus b times a plus b. So this is really a FOIL. The common mistake people will make is say that this is a squared plus b squared, and not true if you do out the steps. A times a would get you a squared. On the outside you'll get an ab, on the inside you'll get ba, which is ab, and then at the end you get b squared. And then combining those like terms, 1ab plus 1ab gives us the 2ab we see in the formula down here. So all this formula is saying is if you write these side by side as they really are and you do your steps, you're going to eventually get here. And so what we can do is use that, since this is the answer is always going to take this form, we can shortcut and not do all the steps of FOIL. If you hate what I'm about to do, you can always just write them side by side in FOIL and you will get the right answer. That said, the next thing we're going to do in this section is then take this side and go backwards and factor. And for that, these are very, very handy. So let me show you a little bit what that will look like. For this first one, I am going to do out the FOIL just once to kind of show where these pieces are coming from, and then try to show how I'm going to use that with the formula. So if I was just going to do this out the way that we did in chapter, I think it was 5, x times x would be x squared. Here we're going to get a minus 3x. Inside we're going to get a minus 3x. And off the last we'll get a plus 9. So here's that minus the 2 of the things. That's why there's that 2 in the formula. And we would end up with x squared minus 6x plus 9. So that's if we do FOIL. And the idea is to kind of skip pretty much these two lines and just go from here to writing down the answer. So if we kind of match these up, the x is the a and the 3 is the b. If in class I'll get the question, should we do minus 3 or 3? What I would say is the signs are right in this formula, so don't mess up the signs. So just treat it like a 3, and the fact that it's negative is already accommodated for in that negative 2ab. And when you square it, it'll be a positive. So just use the signs in the formula. So anyhow, a is x, b is 3. So this first thing is supposed to be an a squared. So since a is x, x times x is x squared. 2ab, this is a and this is b. So all I do is I go 2 times x times 3. I just multiply these two things together and I double it. So 3x times 2, so that would be minus 6x. And that's where I'm just using that sign. And then on the end, it's always going to be positive, even if this is negative, because negative 3 times negative 3 would make the positive 9. So don't overthink it. Just go, yep, it's positive. And then this is supposed to be a b squared, so 3 squared makes 9. So one more time, I'm going x times x, x squared, 2 times 3 times x, that was the 6x in the middle, and it's 2ab, so 2 times 3 times x, and then 3 times 3 on the end. After I do a few more of these, they get really easy and you end up not having to do all this stuff right here. So let me do a few more examples. So this one is x plus 9 quantity squared. So this is going to be x times x, a times a, or a squared up front, so that's x squared. And then we just do 2 times whatever is sitting here. So 2 times x times 9, that would be 18x, and this time it's a positive because that's a positive. And then 9 times 9 plus 81. So if we wrote them side by side and did all the FOIL, this is exactly where we'd end up. So it's just a way to get there a little quicker. This next one, so 7x times 7x, which would be this squared, would be 49x squared. And then 2 times 7 would be 14x times 1 is still 14x. That's a minus that time because of the sign. And again, I'm just multiplying these two together and doubling. And then 1 times 1 is 1. And then this one is 3x times 3x, so that is 9x squared. 3 times 5 would be 15, and then double that would be 30. So it would be plus 30, and then x and y. It's just like we multiply those two together and multiply by 2. And then 5y times 5y would be 25y squared. And then just a couple more with different powers going on inside, but same exact idea. So here we would just be doing t squared squared, or think of t squared times t squared. So that would be t to the 4th. And then multiplying these two things and doubling it, we'd have 2 times 7 would be 14t squared. And then 7 times 7 would make 49. And then this one, that is a 4r cubed. So if I think of going 4r cubed times 4r cubed, that would be 16r to the 6th. Multiplying these together and then times 2 would be 4 times 5 would be 20, and then times 2 would be 40. So minus 40 r to the 3rd. And then 5 times 5 is 25 on the end. These next three are examples of the third formula that was on the sheet. The first two were a plus b and then a minus b quantity squared. So those are where we have the same sign. This is where we have one each side. So we have one positive and one negative. And if I fill that out, let me just show you what happens. A squared, on the outside I get a minus ab, inside I get a plus ab, and on the end I get minus b squared. Those cancel each other, and then we're left with is called a difference of squares. So it's a pretty common formula that you'll run into a bunch. So anytime we have these mixed signs, what we're going to get is an a squared minus b squared, or a difference of squares. So that's really nice, because then when we look at this, we can just go, it's just going to be the thing squared minus the thing squared. So this is like y squared minus 10 squared, or y squared minus 100. And then you don't have to do all those steps and do the canceling, because the only thing that can happen is you can just mess up the signs and then not have a cancel. So much better to just know what that's going to do and do it. So like for this, 3x times 3x would be 9x squared, minus 7 times 7 is 49. And there's no reason to make that problem any harder than that right there. This one, 3 times 3 would be 9, y squared makes y to the 4th. And then minus 2 times 2 would be 4. Okay, so then up next we're going to go backwards. So here we have the same exact formulas we had on the last page, but written in the other direction. And now we're going to see things that look like this coming up, and then we're going to have to get them to the quantity squared version, or the factored version. So these can look like problems that we did in the last chapter of trinomials. These still have 3 terms, and we have these ones where we could ask what multiplies to be 81 and adds to 18. That would get us to the same spot. But you can see something like this if we try to do it like we did in the last section and went 36 times 121. We would get a large, terrible number, and that would be really hard to work with. If you know this section's material, you can look at that and you would know the answer is going to be 6x minus 11 quantity squared. And it's just that easy. So it's definitely good to have more than one method of factoring, because depending on what you're trying to factor, sometimes one thing will work better than another. So I'm going to start with the trinomials. And in terms of spotting these in the midst of other problems, during our steps, step 0 is still greatest common factor, as always. And then step 1 on this is just basically identifying it. Are there perfect squares on the ends after you get the GCF out of the way, if there is one? And if you see perfect squares, it's probably one of these. And what I do is I kind of pretend like it's going to work. I do it and I check myself. And pretty much if it looks like one of these, especially in this course, it is one of these. But I'll show you that little check step. I wrote out just a list of the perfect squares 1 through 12. So the numbers that you're going to be looking for, these are kind of the things that are going to tip you off that it's one of this style problem. So the one that I was kind of making fun of with the big coefficients, if you look 36 and 121, I know that's not going to actually probably be terrible, because 36 and 121 are on my list of squares. So it's probably going to be this formula. So that's how I'm going to determine, when I see a factoring problem in the midst of some other stuff, what method I should use. So for this, squares on the ends, that's the tip. So let me show you how it works with some problems. This first one, if I did it sort of the old school way of what multiplies to be 81 and adds to be 18, that's not too hard, right? We could just say plus 9 and plus 9. And we certainly wouldn't need the formula for that, and that may very well be the way that you look at that one. This is the same thing, though, as x plus 9 squared, and that's what sort of is important, is to realize that you're getting to the same place, just thinking about it 2 different ways. When I'm looking at this, if I go, if x squared is like the a squared in the formula, then x is the a. If 81 is like the b squared in the formula, then 9 is the b. The thing I was saying earlier about I just pretend like it's going to work and then I check it with that 18. So I'm doing if I FOIL this back, I should have x squared, and then we go 2 times a times b, that'd be 2 times 9 times x. There's that 18x. So that's the little, I just assume it's going to work, and then I double check that middle term and make sure it did. This one, same thing. You could look at it and go, oh, I bet it's just going to do, x minus 8 squared, which makes sense because this is x times x, 64 is 8 times 8, and then 2 times x times 8, there's your 16. Likewise, you could have looked at this and said what multiplies to be positive 64 and adds to be negative 16, and thought of it that way. So for these first 2 examples where this is a 1 out front, the formulas aren't, it's fine. Either way that you want to look at it, it's cool. As soon as we get to here, now we're into like what multiplies to 36 and adds to be 12. And that starts getting to be where we have to do a little bit more work with either the AC method or magic. But if we notice again, 4 and 9 are both perfect squares, it makes me want to just kind of like take the square root here and go, okay, what times what is 4x squared? Well, that would be a 2x. And then what times what makes 9? That would be a 3. And then just check the middle term. 2 times 3 is 6, double it, 12. Yep, that was it. And so if it was one that I had to do AC method on, or magic, whichever you prefer, then I would grind that out now, but it didn't take me very long to check that. It would be way more annoying to do the long version and then go, oh, I could have done the short version. So if you see those squares, if you look at everything coming up, right, 64 and 9, 36, 121, 49 and 1, when you see those perfect squares, that means it's going to be an easy problem. So this one, 64x squared, that would be an 8x. And then 9 would make a plus 3, quantity squared. 8 times 3 is 24, double it, and there's our 48. This one down here, so that'd be a 6, and then minus 11, quantity squared. This one, 49x squared, so that'd be 7x. And then r squared would just make an r. And if I went 7xr and doubled it, there's our 14xr in the middle. Okay, and then lastly, we have difference of squares. So anytime when we're factoring and we see 2 terms, at least in this course, if we've already gotten the GCF out of the way, it's going to be one of these or it's done, and it was just a GCF problem. Those are kind of the only two cases we're going to look at here. So x squared minus 16, x squared breaks down to x's, and 16 breaks down to 4 when we take our root. So that will be x squared plus 4 and x squared minus 4. So before, with the 3-term ones, we're getting 2 of the same factors, either both plus or both minus. With the 2 terms, we're getting 1 of each sign. So think 2 terms, 2 separate factors, opposite signs. 81x squared minus z squared, so that would be 9x and then plus z, and 9x minus c. Here, this doesn't quite work because 50 and 98 aren't perfect squares, but what these x squared, y squared on the end is kind of telling me, I bet there's some squares coming up. So if I take a little closer look, I could take a 2 out of there, and that's that the greatest common factor ends up hiding kind of what to do sometimes. So if you get that factored out of the way, it becomes much more clear. So 2 out of 50 gave me 25. 2 out of 98 is going to give me a 49 y squared. And then I got 5x plus 7y and 5x minus 7y. Here, again, 2 terms, there's a common factor going on, so let's get that out of there, and then we'll be able to see what we have left. So it looks like we can do a 2 and a y. So that will leave me a 4y squared and then minus 49. And now I can see those squares and deal with those. So 2y plus 7 and 2y minus 7.